Hello guys, welcome to Pepcoding, and now we are going to discuss the next question, that is construct a binary tree from the pre-order and in-order traversal. So in this question we have been given the pre-order traversal and in-order traversal. Okay, so we have been given the two arrays of pre-order and in-order traversal, and by using these two arrays we have to construct a binary tree. Okay, so let's see how can we do this. So see, so we have been given these two things. First array is the pre-order traversal and the second array is the in-order traversal. Okay, so by using these two array we have to construct this tree. Okay, so let's see how can we do this. So when we do the pre-order traversal, that is, so this is the pre-order traversal. First when we move, so first we found the root node. Okay, then we found 1 3 7 8, then again we move toward this side, then this side, and then this side. Okay, so first we traverse the left hand side, all the node in the left hand side, then what we do, then we traverse all the node in the right hand side. Okay, so in pre-order traversal we have found two things. In pre-order traversal we have found two things, that first node is root node. Okay, and what is the second thing which we have analyzed it? Like first we got the left side, left node, and then we got the right node, all the right node. Okay, so first we got all these node, and then we got all these node. Okay, so we have seen the two things in pre-order traversal. Now let's move towards the in-order traversal. Okay, so let me write all thing. This is the root node. We already know the root node now. Okay, with the help of pre-order traversal we know the root node. Okay, so we have to take the help of these two arrays and we have to construct the tree. Okay, so let's see in in-order traversal. So let's see. So when we move toward when we do the traversal of in-order, so first we got the 7. Okay, first we got 7, then we found 3, then we got 8, then again we got 1, then we got 9, then we got 4, then we got 8, and then we got 0. Okay, so in case of in-order traversal, first we got all the left hand side nodes. Okay, all the child node of left hand side of the root. Okay, so first we got left side nodes. Okay, all the left side node, then we got root. First we got left hand side, then we got root, then we got all the right hand side nodes. See, first we got 11, then 5, then 2, then 6, and then it will backtrack. Okay, then all right side nodes. So in order we have to take care of these things. Okay, so I am going to take the help of these things. Okay, so what I will do is, let me just erase all these. Okay, now I know the root element. So what I will do is I will traverse to the root element. So I will directly move towards the root element. Okay, somehow I will find out the root element. Okay, because I know the root element is 0. Okay, then I directly jump toward the root element. So in order I have found the index of the root element. Okay, then what I will do is, now in this case I already know, like these elements are the left hand side. Okay, these element will come to the left side of the root node. Suppose this is the root node, so all these element will come to the left hand side. That is 7 3 8 1 9 4 10. So all these element will come to the left hand side to the root node. And what is the second thing? all these elements which are right side to the root node will come to the right hand side in the tree. Okay, so 5, 11, 2, 6, all these elements are the right hand side. So let's see this, let's match this. So 2 is here, 5 is here, 6 is here, 11 is here, and all the elements which are in this side, left hand side, are there only. Okay, so we have find out this. Now let's move toward the pre-order. Okay, so let's move to the pre-order. Let me first control Z it. Okay, so again, one more thing what I will say is, I have discussed in pre-order traversal, first root node come, then all the element toward the left side, all left element come, then all the right node come, all right node come. Okay, this we have discussed. So first what I'm going to find out, I'm going to find out the root node in inorder. So for this, how we are going to find out? So let me calculate it here. Okay, so find root in inorder. So let me take index. So I'm going to find out the find index of root in inorder. Let me take idx, that will equal to the 6. Okay, so how I am going to find out 6 here? So first I will initialize idx with 0. Then what I will do is, I am going to traverse it. Okay, so I am going to traverse in inorder array up to when? Up to we found the root element. Okay, so let me write the code. See, I'm talking about this thing. So I'm going to traverse it while in order in of idx is not equal to pre of what is the index, that is starting. Let me introduce with psi, that is pre-starting index. Okay, because pre-starting index is the root index. Okay, if this condition holds true, that means it is not equal. So what I will do, I will just simply increase the value of idx, and in the end what is going to happen, first idx will point to this. Okay, then it is not equal to the root element. Then what I will do, what I will do is, I'm going to increase the value of idx. See, now again it is not equal. Then again I will do idx plus plus. Again I will do I plus plus. Again I will do a plus plus. It is not equal to 0. Again it is not equal to 0. Again it is not equal to 0. Again it is not equal to 0. Now array of in of idx is equal to the pre of psi. That means now in this index we find out the our idx value. So we have to just what will happen, while will be terminated. Okay, and we can find out the value of idx, that is 7. Okay, so by this way we have find out the value of idx. So idx will become 7. Okay, now what will be the value of total element? So the second thing which we are going to find out is the total number of element. So this is idx, and all these elements, see, all these element are the left side element, and all these elements are the right side element. Okay, so these elements are these. Let me do this. These elements are this. Okay, so we have segregated the elements. Okay, so what is the second thing? How can we find out the left side nodes in pre-order array? So what I will do is, I'm going to find out one more thing, that is total number of element. Okay, with the help of total number of element TELE. Let me write the name with TELE. Total number of element. Okay. So I'm going to find out the total number of element. And what simply I will do is I will find out the total number of element that is equal to 1, 2, 3, 4, 5, 6, 7. Okay, so I will just increment the 7 here. See, suppose I got 7 here. Okay, because there are 7 number of element. So if we got 7 here, so what I will do, I will just increment the 7 value here, like 1, again plus 1, 3, 4, 5, 6, 7. So if I will increase the value in, this is the value of PSI. I have just given a variable name that is pre-starting index. Okay, and if I will increase the value of TELE, that will equal to the, that will point to this element. Now all these element are the element which are pointing towards these element in case of pre-array. Okay, so let's I will do it further. Okay, so let me just control Z and I will do once again. So first I'm going to find out the total number of elements. So how can we find out the total number of element? The total number of element can be find out by, I will just decrease the value. So let me take 4 pointer. Okay, so let me take the 4 pointer. What is the first pointer? The first pointer is pre-starting index. The second pointer is in starting index. Okay, and then pre-ending index and in ending index. So I am going to take these 4 variables here. Okay, so now in starting, what is the pre-starting index? In starting, the pre-starting index will equal to the 0, comma, what is pre-ending index? That is 11. And what is ISI? That is in starting index, that is equal to 0. What is in starting in ending index? That is 11. So in starting, we will find these 4 variables. Okay, pre-starting index, that will point to the first index, and in and pre-ending index, that will point to the last, and in starting, that will point to the first in array, and then IEI, that is in ending index, that will point to this. Okay, so I'm going to take the help of these 4 variables. So let me store these variables also. So actually now it will work. Okay, so let me store it here. So these are the 4 variables. Okay, so I'm going to find out the total number of element. And what is the value of total number of element? I will just decrease with 0, like IDX minus 0, that is 7 minus 0, that is 7. That will be the total number of element. Okay, you just simply have to do the B minus A if you want to exclude this one. Okay, so like suppose if you want to find the total number of element, what you do? Just simply do the B minus A. So this will exclude this and include this one. Okay, so we already know this formula. So what I will do, I'm going to IDX minus, and what is the starting index? ISI. Okay, so we are just writing all these values. Then what I will do, I will connect all these dots. Okay, so I am writing all the formula here. Then when I will do coding, then I'm going to connect all these dots. I will also show you the formula which we have written. So that's why I'm storing it. Okay, so now we have segregated it. So now we know, like up to this is our ISI, and we already know like how we can jump toward this. I'm going to, what is the starting index of this? So I'm going to find out these elements. So I need to find out these elements. I have to divide these elements. Then I'm going to use the faith column. So let me introduce for the faith call, like how I'm going to call these. Okay, so let me shift it here. Okay. So what I will do is I have find out this root element. Now this root, we will create this root element here. Okay, we can easily find out the root element. Okay, but we just simply see the first index of preorder. You can easily find out the root element. Then what will happen? This root element give the two calls. Okay, the first one, the root element will say, so up from 0 to 6 element, go and create your binary tree. And after creating your binary tree, just attach to my left. Okay, so it will order these elements to go and create their binary tree and attach towards the left of his root node. Okay, so 0 is going to order all these elements. See, like this. 0 will say 7, 3, 8, 1, 9, 4, 10. All these elements go and create a binary tree and attach to my left hand side. Okay, and it will also say order to these elements also, that 11, 5, 2, 6 go and create your binary tree and attach to my right. Actually, this is the faith call. Okay, I'm talking about the faith call. This is the faith call. Okay, and in the starting we are receiving these four indexes. What are these indexes? We have already talked about. The first one is the PSI, pre-starting index. What is the second one? Second one is pre-ending index. Okay, 0 to 11, 0 to 11. Okay, and what is the starting of this third one? In starting index. And what is the second one? In ending index. Okay, so we will receive these argument, and what will happen, what is going to happen, we can find out the root element from these array. Okay, so in this big array, we know the first element is the root element. Okay, now we have to find out all these four vertices, all these all these point in this call also and in this call also, and how we can find this. Okay, so we need to figure out this. So this is really important. Okay, so let me find out all these. So this is the left call. Okay, so let me separate this here, and it is the left side. So first what I'm going to do is I'm going to find out the PSI for left. Okay, I'm going to find out the PSI, PEI, and ISI and IEI. So I'm going to find out the four vertices for left hand side as well as for right hand side. So what is the value of PSI? PSI will start from, actually this was the earlier PSI. It will increment by 1. So now what is the left hand side? See, this is the array. So let me write it clearly. So let me segregate the array actually. Okay, let me segregate the array. So this is our array. Three, 4, 5, 6, 7. 4, 5, 6, 7. Okay, so 1, 3, 7, 8, 4, 9, 10. Okay, so these elements will go and create their BST, and in case of inorder also 7, 3, 8, 1, 9, 4, 10. Okay, now let me divide for this side also. So there are only 4 elements, 3, 4. Now these are the 2, 5, 11, 6, 11, 5, 2, 6. Let me write the index also, 8 and 11 and 1 and 7. So we have to find these. Okay, so this is what we are doing. We have to find this index, this. So then we are going to pass like this. Okay, so let's see it. So what is the value of PSI? PSI is simply it is equal to the PSI plus 1. Okay, so what was PSI? 0 plus 1. So it will equal to the, let me write with this, PSI plus 1. Okay, so what will the value of PSI? PSY is 0. 0 plus 1 is equal to 1. So we have find out this. So this is this is in. Okay, so we have find out the PSI. Now what is the value of PEI? PEI will equal to the 7. That is equal to 0 plus total number of element. That is PSI. I will just request you to please pause this video and just think about all these coordinate, all these points. Okay, then just cross check it. Okay, so now I'm going to write all these points. So PEI will become PSI. This was our PSI, and I'm going to add with total number of element. That will be the 7. What were total number of element? See, this was the total number of element. PELE. So now we have find out the PEI. Okay, now let's see about LSI. What is LSI? Is the left starting index. That will be equal to the LSI only, left starting index, and up to how much it is going to end? It is going to end IDX minus 1. Okay, so this is the ending index of this. Okay, so let's write the same thing for this side also. Okay, so first I'm going to write the index. So what is the PSI? PSI will become PSI plus 1, that is 0 plus 1, 1, comma, PEI will become 0 plus TELE, that is 7. So it will become 7. Then I'm going to write ISI. ISI will become is equal to ISI only. Okay, so that is equal to 0, comma, IEI. Now we are going to find IEI, and what is the value of IDX? Let me see it here. That is 7. Okay, so 7 minus 1, that is 6. Okay, so this is what we are going to find. Okay, so if we can find out the index of ISI, you can see that. You can see it here. The index are 0. It is starting from 0 to 6, and they are starting from 1 to 7. Okay, so don't confuse in it. Actually, this is somewhat shifted toward the left. Okay, so they are starting from 0 to 6, and it is starting from 1 to 7. Okay, so this is what we have to write. Now let's do from same thing towards the right hand side. So now I'm going to write the let me shift it here only. Now I'm going to write the PSI and PEI, and then ISI and IEI. Now again I'm going to write all these 4 coordinates. Okay, so what will be the value of PSI? PSI will be the, see, PSI will become the IDX plus 1 in case of ISI. First I'm going to write these 2 values because these are very easy. Okay, so IDX plus 1, and what is the IEI? IEI will become the same as IEI. Okay, so this we can easily understand. Okay, now we have to find out this. Okay, so how you can find out this? It is actually the 7 plus 1, and we have already find out this value. Where we have find out? We have already find out by PEI. Okay, so first what I'm going to do, I'm going to start from here. Okay, so I'm going to first jump it from here, then I'm going to take one step. So it will start from here. So PSI plus 1, then plus total number of element, then plus 1. So this is how we will reach in this point. Okay, so I will take PSI plus 1, then plus TELE, total number of elements, then plus 1. So this is how step by step we are going to reaching in this point. So what is the value of this point? This is PSI plus 1 plus, actually this is PSI plus TLE. TLE is actually the 7. If we increase 7 here, so it will directly jump. So actually I have done one step wrong, so let me correct this. Okay, so we are having total number of element is 7. TELE is equal to 7. So what I'm going to do is I'm going to jump from starting point to 7, directly 7. That is 0 plus 7. Okay, PSI plus total number of element. I'm going to jump directly here. Then what I'm going to do, then I'm going to take the one step. Okay, so what will be the value? PSI plus total number of element, then I'm going to increase by 1. Okay, and what is the value of PEI? PI is actually the PEI will actually, it will equal to the PEI only because it is 11. Okay, it will always be the ending point. So like this way we can find out all the 4 coordinates. So this is the important part in this question. Okay, so how we can find out the question? Again, let me repeat the same thing soon. Okay, so what I will do is, so again, now I have to again use the 2 calls. So first what I'm going to do, I'm going to use the calls. Okay, so what will be our root element in this position? So in this position our root element will be the 1, that is the first index. Okay, so now IDX will equal to here. Okay, and total number of element, so IDX, let me write the value of IDX, that is 0 1 2 3 3. Total number of element will equal to the 1 2 3, that is 0 minus 3 0 plus 3, sorry, B minus A. B is 3 minus 0, that is equal to 3. So these are the values. Okay, so what will be the value of these calls? So now we already know, like we have placed root node. Now what is going to happen? We have to separate this into 2 parts. Like one will give the order to 738 and say go and come in the form of tree and attach to my left hand side. Okay, 738. Okay, and what is 378? These are the 1 plus total number of element. See, this is, we are going to find out the PEI, that is pre-ending index. Okay, so again it is going to give the order to these elements, and toward the right side it is giving order the 9 4 and 10. Okay, so this is how again they will choose the root element. So again one by one all the root element will come into the position, and this is how we are going to do this question. So now I'm moving towards the coding part, and we will see one by one how we are going to code this question. Okay, so let's move it. So now I'm going to code this in C++. So let me do the full screen. Okay, so this is our method. So first what I'm going to do is I'm going to create one more method. Okay, so it is not C++. Let me change the compiler. C++, and what we have to do is now I'm going to create one more method. Okay, one more function. So construct tree, create tree. Let me take a simple name and I'm going to call it from here. Okay, and what are the things which we need to pass in this method? Okay, so let me do this small. This is better. Let me do this one more. Now this is better. Okay, so first what we have to do, we have to pass the PSI, PEI, ISI, IEI. and we will also pass that these two arrays. Okay, so let me do this. So first I'm going to pass the preorder and psi, then pei, and then in order. So like in fact I will not pass this variable because I have not initialized it. I'm going to pass the value, okay, the starting value. Okay, so isi comma iei in in ending index. Okay, so let me initialize it here. Int psi comma int pei, and let me move forward, int isi and int iei. Okay, so this is what we are going to do. Then in starting, what is the value of psi and pei? Psi and pi will be 0 and 11, that is 0 and length minus 1. And same here also, in order, the isi is 0 and iei will be length minus 1. So let me take one more variable, that is equal to n. And what is the value of n is preorder, or you can also take the in order because the like size will be equal. Okay, order dot size minus 1. Okay, so this will point towards the last value. So let me take this only. This is the length of the this array. So what will be the value of psi? Psi will start from 0 to 11, that is n minus 1. Okay, and what will be the value of isi? Isi will start from 0 to n minus 1. Okay, so we have do the calling. So now let's do the coding part. Okay, so first what we have to do, see, first I'm going to create a root node. Okay, so again and again I'm going to create the root node. Okay, so in each call I'm going to create the root node. Okay, so the first step is create the root node. Create the root. Okay, so what will be the root node? Root node we can create by this method by creating this object. Okay, node, I will take root new tree node. And what is the value of this root node? The value of this root node is the starting index of pre-array. Okay, so let me take this pre-order, and what is the starting index? psi, pre starting index. Okay, so now we have created the root node. Now what we are going to do, see, now we are going to find out the index, like where the what is the index of root node in the in order. So how we are going to find out the index? So let me write it here. Okay, so let me take one variable, that is int idx, that will start from psi. Okay, it will start from, so not psi, it will start from isi. And in starting, the isi is equal to 0. Okay, so it will start from isi, and then what we have to do, we have to use a while loop. See here, we have used the while loop, like in idx is not equal to pre psi. So I will use the same thing, while in order will start from idx is not equal to root node, and root node is preorder of psi. This is our root node. Okay, then what we have to do, we have to just increment the value of idx, and it will terminate when we will find the value of root node. Okay, so now we have find out the value of root node. Now what we are going to do, we are going to find out the total number of elements, how many elements are present. Okay, so what is the total number of element? So it is the total number of element in the left hand side. Okay, so these are the total number of element. Okay, so by this we will segregate with the help of this TELE. By the total number of element, we are going to segregate the pre-order in the form of two parts, that is the left hand side and the right hand side. Okay, so that's why we are finding the total number of elements. TELE, that is total number of element, and it will equal to the, see, we have already mentioned it here, IDX minus ISI. So let us write it here, IDX minus ISI. Okay, so we have created the total number of element. Now what is our third step? Now what we are going to do? Now we are going to call the, we are going to do the calling part, this thing. Now we are going to call the left hand side and we are going to divide this array and we will attach to the root of left. Then we will use the call of right function. Then again we will use the call of left right. Then again left right, left right. So all the root node are going to create the tree. Okay. So this is actually the high level thinking. So okay. So what I'm going to do is I'm going to call the root node. Okay, so I'm going to attach to the left hand side. Left. This is actually the left call. So I'm going to create tree, and what I'm going to pass pre-order. Now I have to change these value PSI, PEI, and I'm going to write the in order and ISI and IEI. So these will be changing. We are going to change these values. Okay, so let me just copy paste, and in the end I'm going to change these values. Okay, so now what will be the value of PSI of for the left call? So these are the values we have already find out. Okay, so these are the values for the left call. It is actually for the left call and this is for right call. Okay, so PSI will be equal to the PSI plus 1. So let me write it here, PSI plus 1. And what is the value of PEI? PI is equal to PSI plus total number of element. PSI plus total number of element. Let me write it here, PSI plus total number of element, TELE. And in case of in order, so ISI and IDX minus 1. ISI and, let me write it here, IDX minus 1. Okay, so now go to the, move toward the right part. So let me shift this to here. Okay, so these are our PSI and PEI value. PSI is equal to the PSI plus TELE plus 1. So we have already figured out these values, PSI plus TELE plus 1. And what is the value of PEI? PI is equal to PI only, and ISI is equal to IDX plus 1, and IEI is equal to IEI only. We only need to change the value of ISI, that is IDX plus 1. Okay, let me cross check it here, it is IDX plus 1. Okay, so now we have also used the both the calls. Okay, now in the end what I have to do is I have to return the root node. Okay, so what I have to do, I have to just return the root. Okay, now only the last thing which is left is, that is the base condition. So how I'm going to find the base condition? Okay, so now we have to figure out the base condition. Okay, so let's see how we can find out the base condition. Now what will be the base condition? See, now there are three elements. So now what will happen? Now one element is from left and one element from right. In the end what will be happen? Now the PSI value is always less than PEI. You can think about it, like PSI is always less than PEI. See, so in this condition, like here the PSI is greater, the PSI is less than PEI. You can see it here, PSI is less than PEI. Again it is less than, because it is the starting index. It is the starting index and it is the ending index. So if suppose if ending index is less than PSI, or you can write it like this, if ending index is less than psi, or you can say it, if psi is greater than pei. See, now psi is here and pei is here. Again it will shrink, the like in each iteration the array is going to shrink it. So again psi will pei will around come here. Okay, and when the pei will surpass the psi, that means if the value of psi is greater, that means it is past the pei value, that in that case what we have to do, we have to return, what we have to return, we have to return the null. Okay, then in that case our array will not be created, our array is blank, we have created all the element in the node. Okay, so I will write the base condition also. So when psi is greater, psi is greater than pei, then in that case what we have to do, we have to return the null, return null, ptr. Okay, so in that case what we will do, we will return the null. So this is our base condition, when our starting index will surpass the ending index, or you can say that when the ending index is smaller. Okay, then in that case we have to return. So let's run this and check for the compile time error. So it is accepted. So let me submit this for all the test cases. So all the test cases are running fine. So thank you guys for watching this video, and we'll meet you in the next video.